Hey everyone, welcome to Code Harmony. Today we are going to see LeetCode problem number 2461, maximum sum of distinct subarray with length k. It's a good sliding window problem and has been asked in these companies including Amazon, Google, Microsoft. Let's have a look on the problem statement. Here I will be given an integer array nums and an integer k like this, and I have to find the maximum subarray sum of all the subarrays of nums that meet the following condition. What are these conditions? The first condition is that it should be of size k, and the second condition is that all the elements in the subarray should be distinct. This kind of question we have already solved, and we know that this is a sliding window problem where we have to consider all the subarrays and then keep on capturing the maximum value. But here one more condition is introduced, that all the arrays should be distinct. So first of all, let's try to see if we do not have this condition and my elements in the array are unique. What should be our approach in that case? As we have to see all the subarrays of size k. What is a subarray? Subarray is a contiguous piece of this array. So what is my first subarray? First subarray is 154. Second subarray is 542. And third subarray is 429. And here if you try to see that this portion I'm calculating 2 times, this portion I'm calculating 2 times. So if we try to go with the brute force, that we are iterating over this array using index I, and in every step I'm going k times to see my current sum of that current subarray. It will go is in this time complexity, order of n into k. So to avoid this, we usually do sliding window approach, where we do not have to process every subarray one by one. If we have this answer, I can go to this answer by adding one more element in the sliding window from the back and ignoring one element from the starting. So we require 2 pointers, begin pointer and ending pointer. And initially I can keep these 2 pointers initialized to 0, which is the first element. And I can iterate over my index using I index variable. And whenever we are doing sliding window approach, so we have to consider 2 main points when we are writing the algorithm. First of all, we are definitely going to iterate over the array. The first main point is when we have to discard the element from the sliding window, and the second one is when we have to capture the result. So when I'm going to discard the element from the sliding window, if my sliding window size is getting increased, then k. Here I is the pointer I'm using to iterate in the array, and b is my beginning pointer, e is my ending pointer, or you can say I is equal to ending pointer. Using ending pointer I am iterating over the array, and b is my beginning pointer. If the sliding window size is crossing the value k, then I have to discard the element from the left. So in the first iteration, beginning ending both are at 0. Beginning is at 0, ending is at 0. After one iteration, and I will also capturing the current sum. Current sum will consider as my sum of my current window. Current sum is 0 in the starting. So if I do the iteration, current sum will be equal to, first of all I will just capture the current sum. Current sum is 1. And then I will see, do I have to discard any element? No, I don't have to discard element. How did I decide? Checking the size of the current window. Size of the current window is ending pointer minus beginning pointer plus 1. This is the size. If the current window is something like this, beginning is at this, ending is at this, the size is 2. 1 minus 0 plus 1. So the size of the window, if the window is greater than k, in that case I have to discard the element from my window. So the first condition will map to this expression. So here when my current index, or you can say ending index is 0, I don't have to do anything. When my ending index is becoming equal to 1, my current window is 1 to 5. 1 and 5. These 2 elements are in the window. And the current sum is from 1, it has become equal to 6. Do I have to discard any element? Current window size is 2. And the value of k is 3. So this expression is not fulfilled. Now we don't have to discard any element. And can we capture the result? While capturing the result, we have to make sure that the current window size is equal to k. And what is current window size? Ending minus b plus 1 is equal to k. If this expression is giving us true, we need to capture the result. And if this expression is giving us true, I need to discard values from the sliding window. This is only we have to do when we are having this kind of problem. So let's make a dry run on this example. Current window size is 6, and now when I'm incrementing the pointer and my ending is going to 2, let me mark the indices 0, 1, 2, 3, 4. My current sum has become equal from 6 to 10. Now now do I have to discard it? No, the current window sum is 3, so it is not crossing 3. Can I capture it? While capturing the sum, this expression is giving me true. So I will capture the value in the sum. So maximum sum so far is 10. When I further try to increment the window, the ending pointer will become equal to 3, index 3. And the current sum is 12. Now I will see, do I have to discard element from window? Window size has become equal to 4. Now I will discard items, and discarding item means incrementing the beginning pointer. I will increment the begin pointer. Begin pointer will follow to 1, and along with the beginning the pointer, I will decrement the value of this element from my current sum. First element was 1. So current sum will become equal to 11. Now at the time of capturing, the current window size is 3. I will capture the current sum, which is 11. Now if I further try to increment the ending pointer will become equal to 4. And now I am at 1 to 4. Current window size is 4. I will discard one element from the window, and then when I incremented 4, it became equal to 20. The current sum became equal to 20. And so when I made the window valid, I discarded the invalid elements. It has become equal to 15. So current window is 2, 3, 4, which is 4, 2 and 9. And the current sum is 15. So I will be updating 15 in the sum. If you try to analyze it again, my current window was something like this. And then I incremented this. Then it became this. So this time we will capture the value. When I increment this has become invalid, and now I need to decrement the range. Further, I am incrementing it and decrementing it, and this window is going to give me the maximum answer, which is 15. So I will capture it. So these two steps, when we have to discard elements, when we have to capture. So this is important part. So the same thing will go here. In case if we have duplicate elements, duplicates element, we got one more condition when we are discarding the element. So these two are the expression keep in mind when we do not have duplicate elements. And when we have duplicate elements, let's say when I am iterating over this window, just stay with me, and this is the first element in my window. Window will look like this. Incrementing the ending pointer is further increased. When ending pointer will go at this point, the window size is crossing, and now I have to decrement the window. And when this 9 is getting added, again I have to decrement the window because it is going out of the size. And when I'm trying to introduce this portion, I see that this 9 is already there in the current sliding window. My current sliding window is always from beginning to ending, and E is my current element. So when E is coming here and beginning as here, I will try to see if that window is going out of range. But before it is going out of range, I also need to see what is the previous what is the previous scene of the current element. One more thing to keep in mind, that we are only playing with the current element. That current element is going to be inserted in the sliding window, and our sliding window will always be valid, because in every iteration I am discarding elements to make the sliding window valid. So we can pre-assume that this sliding window from beginning to ending is already valid. Beginning to ending from previous iteration, it was something like this. In this iteration, E has come to this pointer, and now I need to see whether this element is already present in this or not. And how do I see? If somehow I know the last scene of the current element. And what is the current element? Current element is the value. If the last scene of the value, if I know this data, I will be able to see whether that value is from the previous window or not. Let's say this value is j. If j is falling in this window, then I need to do something. It means I need to make my window valid. If let's say the j is coming to this portion, if j is coming to this portion, I'm not bothered about that. It means whether we have seen it previously or not, if it is not violating my current window, so far we are good. But if that j is coming from this window, then I have to make it valid. And how I can make it valid? That current value is val. If val is already in the sliding window, we have to discard all the elements till that value. What I see here, I have beginning pointer, and now I have j. If value of j is greater than equal to beginning pointer, it means that this last scene is in the previous window, and I have to discard that value. I hope you got this expression. This expression should be written in the discarding condition. In the discarding condition, I got one more expression, whether the last scene value is greater than equal to beginning. So here, what is the last scene value? What are the indices first? 0, 1, 2, 3, 4, 5, 6. The last scene value is 4, and beginning value is, for this window, 4 to 9 window, is 2. J is greater than equal to 2. Yeah. So just discard one value. If we are discarding value, beginning value is getting incremented. Now it is still fulfilling. Just discard one more value. Beginning value will become equal to 4. This is again giving true. Just add one more value to the beginning. Beginning value will now become 5. So now ending was 5. Beginning has also become 5. I have discarded all the elements till this range. So nothing fancy in this case. Instead of this condition, this standard condition, one more condition is introduced. So whether I'm considering this expression or this expression, whatever value I'm getting, I can discard on these conditions. Any of the expression is giving true, just discard elements from the window and make my window valid. And in the end, if I see I can capture the window, I will capture it. So I hope the sliding window approach is clear to you. This is my approach. I will iterate over my current window, and instead of I have two pointers, beginning pointer and ending pointer. Ending pointer will go from 0 to n-1, and every step I will see whether that ending element has last seen in the previous or current sliding window. If that is in the current sliding window, I just need to make my current sliding window valid. Okay, so these expression I just have to follow in my sliding window approach. Just do the iteration and discard on this condition. While these conditions are getting fulfilled, just discard elements, and after that I need to capture the current element seen as well. So if the current sliding window is valid, I will capture the last scene of current value as well. Capture the last scene of current value. What is that? I need to capture the index. So this is the key and this is the value. I need to store it in some data structure. What data structure should I choose? I can go with map, hash map. In the hash map, for any value, just store the previously or last seen index of that value. Okay, so this much we have to do. And what is the time and space complexity? Even we have duplicate element or not duplicate element, the time complexity is going to be order of n, because every window we are just shifting the window by 1. The time complexity is going to be order of n. What is the space complexity? Space complexity is also going to be order of n. Let's write down the code. Maximum subarray sum. Answer is expected as long. So taking answer variable, answer initially, if there is no answer, I am going to return 0. Along with the answer, I will maintain the current sum. Current sum is 0, and my sliding window, which is int begin is 0 and ending is 0. Okay, these two variables are also there. So while the ending pointer is less than nums dot length. If that is the case, I need to do something, otherwise I'm good with my answer. So first of all, I need to see the current element. Because I'm processing the current element, I will also take a hash map to maintain the last scene. Map integer comma integer, let's name it last scene, equal to new hash map. Integer, the current element is nums with end. And now I have two conditions to discard my sliding window. One is with size, the second one is the last scene of the current value. What is the last scene? If last scene, let's call it j. J is equal to map dot get or default. I need to get the last scene of current element. If there is no last scene, just get the -1, because indices are starting from 0. -1 is already always full, like discard my condition, which I'm going to use for discarding elements. Now when I have to discard, I will discard the sliding window elements if the last scene is already from the window and window is from beginning to ending. If my j element is greater than or equal to begin, I need to delete the element. Otherwise, if that is not the case, in that case I will see the size of the window. Size of the window is end minus begin plus 1. If that is greater than k, I will discard the element. And how do we discard? Just decrement it from the current sum. Current sum minus equal to nums with begin, and after decrementing I will just increment the pointer. Okay, now I'm having the valid window, and the current sum will also include the nums value, current sum plus equal to nums ending. Along with that, I also need to capture the last scene. Last scene dot put. The current value is current and the current index is end. Okay, here I will decide whether I have to capture or not. When we have to capture, if the current window size ending minus begin plus 1, if that becomes equal to k, my max is going to store the answer. Max, not the max, it is answer. Answer is equal to math.max answer comma current sum. Okay, I have done everything, and it's a while loop, so increment the end pointer as well. Now I think the coding is done. Let's try to submit the problem. It is submitted successfully and beats 87% of the Java solution. Okay, I hope you understood the approach. If you have any doubt, you can comment down below. Okay, bye bye.